In 2.3, we're going to learn about linear functions and slope-intercept form. We'll learn how to graph linear equations and how to write equations of a line. Most of this should be a review from Algebra 1, but I know it's been a while. First, let's look at our 4 different types of slopes. If we were to draw a person going on our slope, we can see that the person is going uphill. And that means the slope is positive. Think you have to put in a lot of energy to go uphill. If we drew a person on our next one, they're going downhill, if we're reading that graph from left to right. And if you're going downhill, it doesn't take lots of energy, so it's a negative slope. Okay, if we draw it again on a horizontal one, notice that there is no slope. The person's just walking in a straight line, so the slope is equal to 0. And then on the vertical one, if we draw somebody, they're just falling straight down. There is no slope that they're on, so the slope is undefined. Now, to actually find the slope, we can use a formula. The formula says we're looking at the change in our y values divided by the change in our x values. And when looking at a change in something, that means we have to subtract 2 values. So we're going to do y1 minus y2 divided by x1 minus x2. In the first example, we can find the slope between these 2 points. First, let's label each of our points. The first coordinate is always x, the second coordinate is y. So the first coordinate becomes x1, y1, and our second coordinate becomes x2, y2. Now we can just plug these into the formula for the slope that we just wrote. So we said we're going to take y1, which is 7, and we're going to subtract y2, which is 4. Then we're going to take x1, which is negative 3, and we're going to subtract x2, which is negative 2. Notice how we're always putting our second value in parentheses, because sometimes we're going to be subtracting a negative. In the denominator, what happens here is we're going to have negative 3 plus 2, and the numerator, we're going to have still 7 minus 4. This becomes 3 over negative 1, which becomes a slope of negative 3. We'll repeat the same process on the next example. So we have x1, y1, and x2, y2. That means we have 1 minus 1 over 3 minus a negative 4, which becomes 0 over 7. Now, if you ask yourself, how many times does 7 fit into 0? It can't. So this just becomes a slope of 0. You could also type it in your calculator and you'll get the answer of 0. Pause the video and give the next one a try. On this example, you'll end up with negative 4 over 0, but we can go one step further with this. Anytime we have 0 in the denominator, that goes against the rules. So if you type this in your calculator, you're going to get an error message. And that's because this is undefined. This means that these 2 points fall on a vertical line. Now that you can find the slope of a line, we can write the equation of a line in what we call slope-intercept form, which is y equals mx plus b, where m is your slope and b is your y-intercept, or where you're crossing the y-axis at. If we look over at our picture, here at the value of 5 is where you're crossing the y-axis, so this is what we call, again, our y-intercept, or we could represent with the letter b. Then, when it comes to finding the slope, we could say we have 2 points, like this point negative 1, 3, and if we want to get to that y-intercept, notice how we go up 2 and over 1. This would be your change in y would be 2, your change in x would be 1, and together you can find the slope with those values. Let's take a look at some examples. When you're given a graph and you're trying to write it in slope-intercept form, you want to first start off by identifying 2 points that can help you find the slope. Let's take this point here of 3, 0. Then we could also pick 5, 4 because it's crossing directly through that grid line. Now to find the slope, we're going to look for our change in y over our change in x. And we've gone up 1 and we've gone over 1, 2, 3, 4, 5. So together that slope is going to be 1 over 5. And remember, we're always putting the vertical change or the y change on top and the horizontal change or the x change on the bottom. Then we need to know the y-intercept, and remember that's where you're crossing the y-axis at, so b is going to be 3. Then we can plug this into the general form, y equals mx plus b, so we'll have y equals 1/5 x plus 3. Next, we're going to skip over to c and do this one first. Notice here how we're crossing the y-axis, not at a whole number, but that's okay. We're just going to have to guesstimate the best we can. That looks to be about -2.5. Or you could also write that as -5/2. Then we can identify our slope. If we look, we don't seem to cross at any perfect grid line, so we're going to also have to estimate here. Here it looks like we're crossing at another half, so that would be a good place to look at. In order to get there, we're going down 1, and we're going across 3. Before you say that's the slope, you need to check to see if it should be positive or negative. Since the line is falling from left to right, or it's going downhill, the slope is now a -1/3, leaving you with a final answer of y equals -1/3 x minus 5/2. Go ahead and give B a try. This is another example of having a negative slope, but this time you're going down 6 units over 1, so the slope is a whole number, -6. Then your y-intercept is 1. Now let's take a look at how we can write an equation in slope-intercept form algebraically. We're going to write the equation in slope-intercept form and then identify the slope and the y-intercept. Since slope-intercept form is always y equals, we need to start by isolating whatever the y variable is. In this case, we're going to start by saying, okay, we want to get -4y all by itself. That means we're going to have to cancel out this 5x, so we're going to subtract 5x to both sides. Just like solving equations from last chapter. Now, we're going to be left with -4y equals -5x plus 16. So notice how we didn't combine the 16 and the -5x because they're two different terms. Also, we wrote the -5x first because it's always y equals mx plus b. The x term just always comes first in this format. Now, we want to get y all by itself, so we need to divide both sides of the equation by -4. And we'll be left with y equals 5 over 4x minus 4. Now remember, whenever you are dividing by some number, it applies to every single item that comes above it. So the -5 is divided by -4, and the 16 is divided by -4. Now that it's in slope-intercept form, we can easily identify what is the slope and what is the y-intercept. The slope is whatever's in front of your x term, so 5/4, and the y-intercept is a -4. Remember, you always need to include signs with your numbers, identifying the slope and the y-intercept. Looking at B, we now have some fractions. But the same process still applies. We start by isolating whatever the y term is. That means we need to add 3/4 x to both sides of the equation. It will cancel out on the left, and you have now 2/5 y is equal to 3/4 x minus 1. Then, to get y by itself, we're going to multiply both sides of the equation by the reciprocal of 5/2. And then remember to put everything here on the right in parentheses, because every single item gets multiplied by 5/2, meaning we're going to use the distributive property. On the left, the fraction cancels out, and you now have just y, and that's equal to, multiply those fractions across, and we'll have 15 over 8x minus 5/2. Check to see if you can simplify any of the fractions, but in this case, none of them reduce, there's no common terms, so here is your final answer for the equation in slope-intercept form. Next, to identify the slope, that would be 15 over 8, and then to identify the y-intercept, that's going to be a -5/2. Go ahead and give C a try on your own. You should have gotten y equals -7 over 6x plus 5, meaning the slope is -7/6 and the y-intercept is +5. Now that we can write the equation in slope-intercept form, ready to learn how to graph equations. The first step is to write the equation in slope-intercept form. Then we can plot the y-intercept. Next, we'll use the slope to find the next point, and then we can draw a line to connect them. Starting off with step number 1, we're going to add 2x to both sides, and that will leave you with -3y equals 2x plus 9. Then divide both sides by -3, and y is equal to -2/3 x minus 3. There is step number 1, putting it in slope-intercept form. Then we can plot the y-intercept. Remember that our y-intercept is whatever the constant is, which in this case is -3. Then we're going to use the slope for step number 3. To plot the next point. Since it's negative, we know our graph is going to fall from left to right. You're going to want to go down 2 points and across 3 to the right, and we can do that 2 times just to get a couple points on our graph. We could also go up 2, but make sure that you go 3 to the opposite direction, or 3 to the left. Now we are ready to connect these points with a straight line, and there we have the graph of that equation. Moving on to B, same steps. First thing we need to do is put it in slope-intercept form. Now we need to get y all by itself, so we're going to want to multiply both sides of the equation by the reciprocal, which is 4/1. Make sure you do it to everything on the right-hand side. So the fraction cancels out, and we're left with y equals, make sure you distribute the 4 to both terms. So that's going to give us now a slope of 8/3 x plus 8. So always just check at the very end. If your slope is positive, make sure that the slope rises from left to right. If the slope is negative, make sure it's falling from left to right. Now let's look at some equations that do not have slopes. Here we have y equals -3. That means that there's no x value to plug in. Therefore, at any point on the graph, y has to be going through the value of -3. If we were to draw the line going up, well, notice here, well, y is 0. Here, y is 1, 2, 3, 4, 5. That doesn't work. But if we draw a horizontal line going through the value of -3, it doesn't matter where you are on the line, at every single point, your y value is going to be -3, just like the equation says. So anytime you have y equals some number, you are going to have a horizontal line. But what if we have an x equals line? See if you guys can do that one on your own. Since x is opposite of y, you're now going to have a vertical line anytime you have x equals some number. And the line's going to go through whatever that value is on the x-axis. So in this case, we have a vertical line through +2 on the x-axis.